Now in this video, we want to find the range of this function. We have it to be that f of x is equal to the square root of 1 minus x, then divided by 1 plus 7x. Well, to find the range of this function, we'll have to first of all replace f of x with y. So let's just do that right away. So replace f of x with y. That gives us y equals, so the square root of 1 minus x, then we divide that with 1 plus 7x. Good. And then the next thing we'll do here is to, now, after replacing f of x with y, we now have to interchange x and y, right? By interchanging x and y, we want to find the inverse of that given function. So we're going to interchange x and y. In place of x, y, we're going to put x, and then we equate that with the square root of 1 minus y, right? Said interchange x and y, 7y. Great. And then the next thing we'll do here is to make y subject of formula, right? So we're going to go through the process, the whole process of making y subject of formula. Well, let's first of all multiply both sides by 1 plus 7x, or 7y. So multiply the left hand side by 1 plus 7y and do that to the right hand side. 7y, right? Good. That means that this and this will just cancel out. And then we are going to expand this side. This is 1 plus 7y times x. That will give us x times 1 is x. Then 7y times x is 7xy. And then we equate it to the square root of 1 minus y. Good. As I said, we want to make y subject of formula. Now, we will have to square this to get rid of the square root. So by squaring both sides, say raise both sides to power 2. Then do the same thing to the right hand side, raise it to power 2. So the square and the square root cancel, and we're going to be left with only 1 plus y, right? But let's expand this left hand side. So we're going to expand that. We're going to have x squared plus 14x squared y, all right, plus 49 x squared y squared. That is just by expanding the left hand side. And then we're going to rewrite the right hand side to be 1 minus y. Good. So from here, we will try to make y subject of formula, but I'm going to rearrange this in a certain form, a form that really makes a lot of sense. I'm going to rearrange it by bringing this one to the first term. I'm going to even move this one to the left-hand side also. That will give us 49x squared, and then I call it y squared. That is this third term here, and then plus 14x squared y, right? And then I'm going to move this y from the right hand side to the left hand side. That will become plus y, and then this x squared plus x squared, and then we're going to move this one to the left hand side. That will be minus 1, and we equate that to 0. Good. Great. And then here on the last equation on that part of the board, if you can observe, this is going to give us a quadratic equation where a is this, then b is this coefficient here, and c is this part. Okay, that is going to be quadratic, but I'm going to have to rewrite something. You see this 14x squared y plus y. I can factor out y from there, and that will mean when I factor out y, I'm going to add 1 in this position, all right? So you just factor out y from there, this will become plus 1. Then you're going to have to multiply the whole of that with y. Great. Okay, that's better. So as I was trying to say, that this gives us a quadratic where a is 49x squared, where a is 49x squared, where a is 49x squared, b is 14x squared plus 1, and c is x squared minus 1. Good. So given that quadratic equation, we are going to use the quadratic formula to get the value or values of y. So that tells us that the first value or second value of y will be, now from the quadratic formula we have negative b, that is negative of 14x squared plus 1, then plus or minus the square root of, so we're going to have to square that b, alright? So b squared, that is 14x squared plus 1 squared, minus 4ac. So minus 4 times a is 49x squared. 49x squared. And then c is x squared minus 1. Right? So we multiply that with x squared minus 1. And then we divide it with 2a. So 2 times a is 49x squared. So we multiply 2 with that. That gives us 98x squared. Okay, great. Now, this expression here under the square root sign, we will need to expand it, all right? We know we have some squares over there. We need to expand it and see what we can do from there. So, by the expansion of 14x squared plus 1 raised to power 2, you can write that twice and multiply them. That is 14x squared plus 1 times 14x squared plus 1. When you do that, it will give us 196x to the 4th power plus 28x to the 2nd power plus 1. That is just by expanding this term here under the square root sign. Good. And the next thing we'll do is to expand this other second term, alright? Okay, let's just ignore the negative sign in front and just expand that and see what we'll get. Well, when we expand that, we're going to have, this is a negative sign first. So let's see. Now, 49x squared times x squared, that will be 49x to the 4th power. We multiply that with the 4. That will give us 196x to the 4th power. And again, 49x squared times negative 1. Then we multiply that with the 4 outside. That will give us negative 196x squared. Great. So we're going to expand this. We're going to remove this bracket that is multiplied through by the negative sign in front. So this gives us negative 196 plus negative 196 plus 196x squared. Good. And then you see that negative 196x to the 4th power will cancel out with the positive 196x to the 4th power. And we are now going to add 28x squared with 196x squared. So 28 plus 196 will give us 224x to the 2nd power. Then we add this one to that. Right, where the other two terms cancel out because they are equal and opposite in sign. Good. So this tells us that under the square root sign, all those terms there, we can replace it with 24x squared plus 1 because this is what we get from the expansion of that. Okay, great. So let me just write it down again. y12 is negative a or b squared, that is negative b, that is that, plus or minus the square root of. So the whole of that will be replaced with 224x squared plus 1, because that's what we get when we simplify that radicand, 98x to the 2nd power. Good. Okay, and now notice that this new y that we've been looking at since is the inverse, right, of that given function. There are two of them. Well, the inverse here is not unique because this function is not a one-to-one function. There are two of them here. The positive here, and then we can write it with the negative sign here. Good. So maybe I can replace this y1 and 2 with f inverse of x. Maybe I just put down the 1 and 2 to show there are two different values there. And now, when we consider the range of a function, we find the inverse of a function, and we look at the domain of that inverse. That will be the range of the original function. So the domain of this inverse seems to be the set of all real numbers except 0, because we do not want to have 0 in the denominator. So if x is 0, that means we're going to have 0 squared, and 0 squared is 0, times 98, which is going to be 0 in the denominator, right? Good. So maybe at first, I'm going to write that the range should be the set of all real numbers, right? Except 0. So I said the range is R except 0. Good. But let's look at the 0 itself. When we talk about range, we're talking about output, all right? We are saying that the range is every real number, that is the output of that function for every given input, will be every real number except 0. So that means we can output every other real number, but we will never get 0 as an output of that function. But let's look at that function again. Look at this function. Is there any way we will get 0 from this function? That is there any way that the value of this function will give us 0? Well, when you have a fraction equal to 0, a fraction is only equal to 0 if the numerator of that fraction is equal to 0, given that the denominator is not 0, right? Good. So at that point, we will have to equate 1 minus x to 0. Then we take the square of that. We equate this to 0. Then the square root of something gives you 0 if that thing is 0. So we now say 1 minus x is 0. From here, we can find the value of x that makes 1 minus x to be 0. And that value of x is that x is 1. And this x is a real number. This tells us that, yes, 0 can be an output given that the input is 1. So if we plug in 1 into this function, the output is going to be 0, which tells us that 0 is actually an output. Therefore, 0 is also a member of the range. So this contradicts the fact that we say all real numbers except 0, right? So because of that, this fails. And we're going to say that the range is going to be the set of real numbers. And that is it. Okay, thanks for watching and please subscribe to my channel.